class, so for today's discussion here in Mechanics of Deformable Bodies, we are now going to proceed to the fourth part of our discussion about shear and moment in beams. So last time, we discussed the flexural stress in beams. Okay, so this time, class, we are going to discuss the shear stress in beams. So for our learning outcome, okay, so students must be able to compute the shear stress in beams. Okay, so let's start our discussion, class. Okay, so if we are going to recall the definition of shear stress from our discussion about the fundamental concept of stress, that is in lesson 2. Okay, so we define shear stress as the stress that measures the intensity of a shear force. Okay, and also, class, what happens in shear stress is that it tends to divide or cut the body into two. Okay, into two parts. Okay, so this time, class, we are going to discuss the shear stress, no, that happens in beams. Okay, so in general, a beam will support both shear and moment. Okay, so in our last discussion, we talked about the effect of bending moment to beams, and yung effect niya nga, class, is bending stress or flexural stress. So this time, class, yung pag-uusapan natin is yung effect ng shear force, no, sa beam, okay, which is the shear stress. Okay, so the shear V is the result of a transverse shear stress distribution that acts over the beam's cross-section. So, class, if we are going to consider a beam, okay, wherein this beam carries a load, no? So, let's say we cut a section of that beam. Okay, so ito, class, yung makikita natin dun sa cut section. Okay, so, class, in this cut section, no, of course, meron tayong makikita dito na internal shear force. Okay, so actually, meron ding internal moment dito, tama ba? Pero hindi natin siya i-consider dito kasi nga shear stress tayo. Okay, so, class, this will be the shear force, okay, na mag-a-act, class, no, dito sa cut section na ito. Okay, and class, itong area na ito, class, which is the cross-section, okay, itong cross-sectional area natin, class, this is the area that will be coplanar, okay, dun sa shear force V natin. Okay, so ito, class, area na ito na coplanar dun sa shear force V natin. So this will be the shearing area. Okay, so again, class, yung shearing area natin will just be the cross section of the cut section of the beam. Okay, so ito yun, class, yung magiging shearing area natin. And in this shearing area, class, if you are going to represent, class, yung distribution ng magiging shear stress dito, ito yun, class, yung magiging stress distribution dito. Okay, so ito, class, yung stress distribution, no, due to this stress tau. Okay, so, class, here, itong stress na to, itong shear stress na to, ito ay tinatawag na transverse shear stress. Okay, kasi, class, itong area na to, actually, class, ito, class, ay transverse plane, no, or transverse area ng beam natin. Okay, so yung stress na mag-a-act dito, class, ay tinatawag na transverse shear stress. Okay, so, class, if we are going to take an element, no, from this section, okay, from this cut section, class, let's say ito yung, class, yung element na kinonsider natin. So this is a cubic element. Okay, so, class, dito sa side ng cubic element natin, okay, so itong side na to, yung stress dito, class, it will be the same stress na nakikita natin dito. So, ibig sabihin, class, yung stress dito sa side na to will just be the transverse shear stress. Okay, so this is the shear stress that acts dito sa transverse area or transverse plane ng beam natin. Wherein yung transverse plane na yun, class, ito lang yung cross-section. Okay? Okay. So, class, due to the complementary property of shear, however, this stress will create corresponding longitudinal shear stress which will act along the longitudinal planes of the beam as shown in this in this figure. Okay. So, class, merong property ang shear. Okay? Yun yung tinatawag nating complementary property. Okay? That if we have a transverse shear stress here, it must produce a corresponding longitudinal shear stress. At yung corresponding longitudinal shear stress niya will be this stress. Okay, so class, itong longitudinal shear stress na to, okay, so this is equal, no, to this transverse shear stress. Okay, and itong shear stress na to, class, it will act along the longitudinal plane. Yung longitudinal plane, class, ito yung plane na along doon sa longitudinal axis ng beam natin. Okay, so sa madaling sabi, class, no, yung longitudinal shear stress natin, ito yung horizontal shear stress. Okay, so in short, class, no, hindi lang pala vertical, kasi ito, class, transverse shear stress natin, ito actually, class, ay vertical, di ba? Ito ay vertical shear stress. So it means to say, class, na for beams na merong mga vertical loads na applied, hindi lang pala vertical shear stress yung mangyayari. Okay, so there will also be a horizontal shear stress. And yung horizontal shear stress nga na yun, class, is yung longitudinal shear stress. Okay? Okay. So we can prove this, class, no, by considering this. Okay, so to illustrate this effect, we will consider this beam. Okay, this beam. So this beam, class, this is made from 3 boards. Okay, so meron tayong 3 boards dito, class. So sila ay magkakapatong na boards. Okay, so hindi sila banded together. So they are unbanded. Okay, so ibig sabihin, hindi ginamitan ito ng adhesive or kung ano mang pwedeng pang-band dun sa 3. Okay, so magkakapatong lang sila, class. So, class, if we are going to, let's say muna, class, na yung assumption dito is yung top and bottom surfaces of each board are smooth. So, hindi natin i-consider yung friction. And the boards are not banded together nga. Then, application of the load P will cause the boards to slide relative to one another when the beam deflects. Ayun. So, of course, class, upon application of this load P, these boards na magkakapatong, okay, they will deform. Okay, so they will deflect, no? Magde-deflect sila. Okay, so, kaya lang, class, ang mangyayari dito, since, ano nga sila, magkakapatong lang sila, class. Okay, what happens is that they will slide past one another upon application of this load P. Okay, so magi-slide sila, magkikiskisan sila. No, itong 3 boards na magkakapatong na ito. And makikita mo yun, class, dito. Tingnan mo itong mga dulo, class, nung boards natin. Makikita mo dito, hindi na sila pantay-pantay, di ba? Hindi na sila pantay-pantay dito. Kasi nga, they slide, okay, past to one another. Nag-slide sila past one another. Okay, so class, on the other hand, no, if the boards are banded together, no, if they are banded together as shown here, okay, then the longitudinal shear stress acting between the boards will prevent their relative sliding and consequently the beam will act as a single unit. So as you can see here, since banded together, class, yung 3 boards natin dito, so magkakadikit na sila, class. So ganito na yung mangyayaring deflection sa kanila kapag in-apply na natin ng force P. So makikita, class, na they already act as a single unit. Hindi na dito katulad na, di ba, they slide, past one another, eh. Diba? Kaya hindi pantay-pantay itong dulo nila. But in this case, class, no, they already acted, no, as a single unit. And class, dito, no, na-prevent yung sliding, no, doon sa pagitan ng mga boards natin. And yung nag-prevent doon, class, is yung longitudinal shear stress. Okay, yun yung stress, class, na nag-a-act sa pagitan ng mga board natin. Okay, ito yung, class, yung longitudinal shear stress na to. So, yun yung nag-prevent, class, kaya hindi na sila nag-slide one another. Okay, nagets mo yun, class. Kaya, class, ayun ha, sa beam, class, hindi lang shear or hindi lang vertical or transverse shear stress yung nag-a-act. Okay, but there are also, there's also horizontal or longitudinal shear stress. Okay, and take note, class, na yung transverse at longitudinal shear stress, they are equal. Okay, they are just the same. Okay, okay. Okay, so as a result of the shear stress, shear strains will be developed and this will tend to distort the cross-section in a rather complex manner. For example, consider the short bar in figure 3A. Okay, so this is the bar that is mentioned here. Okay, so class, this short bar made of a highly deformable material and marked with horizontal and vertical grid lines. Okay, so kapag, class, yung shear V ay in-apply, okay, when a shear V is applied here, it tends to deform these lines into the pattern shown in figure 7.3b. Okay, so this is the deformed, deformed bar. Okay, so plus as you can see here, this non-uniform shear strain distribution will cause the cross-section to warp. Okay, so class, if you are going to apply a shear V, no, to this bar, okay, what happens to the bar, class? It will deform. Okay, as you can see here. Okay, so class, yung deformation dito, class, no, the cross section, okay, of the bar, it will warp. Ibig sabihin, it will be distorted. Okay, so yun, class, yung totoong nangyayari kapag merong kumbaga shear force, okay, na ina-apply doon sa bar or sa beam, nagwa-warp yung cross section, nadi-distort yung cross section, no, nung ano natin, nung bar or nung beam natin. Yun yung totoong nangyayari. Okay, so as a result, when a beam is subjected to both bending and shear, the cross-section will not remain plane as assumed in the development of the flexure formula. Doon kasi, class, 'di ba, sa discussion natin in flexure stresses, okay, yung inassume natin doon, class, yung cross-section, okay, ng beam natin, hindi siya magwa-warp. Okay, or it will remain plain. Okay, pero ang totoo kasi, class, magwa-warp talaga siya. Okay, although this is the case, we can generally assume the cross-sectional warping due to shear is small enough so that it can be neglected. Okay, magwa-warp siya, class, pero yung warping kasi, class, na nangyayari due to shear, that is just very, very small. Okay, na that is enough, okay, to be neglected. Kaya nine-neglect natin. Kaya ina-assume natin na hindi siya nagwa-warp. Okay, so this assumption is particularly true for the most common case of a slender beam. Okay, so slender beam, class, that means that is one that has a small depth compared with its length. Kasi, class, dito sa discussion natin, no, about beams, yung mga beams natin, class, na ina-analyze, they are long beams, no, they are slender beams. Okay, because yung depth ng beam natin, class, that is way smaller compared dun sa length ng beam. Okay, kaya in this case, class, the warping, okay, na nangyayari due to shear, no, it will just be neglected. Okay, okay. Okay, so this time we are going to derive the shear formula that we are going to use to solve shear stress in beams. Okay, so because the strain distribution for shear is not easily defined as in the case of axial load, torsion, and bending, we will develop the shear formula in an indirect manner. Okay, so to do this, we are going to consider the horizontal force equilibrium of a portion of the element taken from the beam in figure 7.4a. Okay, so as you can see here, now we have this beam. Okay, so for this beam, class, we are going to take an element here. Okay, so for this element, class, this has a thickness dx. So this is just a very, very small element. Okay, and the perspective, no, of that element, okay, will be this. Okay, so yung thickness niya, class, is dx. And this will be its cross-section. This will be the cross-section of the beam. Okay. And a free body diagram of this element is shown in this figure. Okay, so this is the free body diagram, class, of this element. So the thickness is dx. So the thickness, class, is dx. And as you can see here, class, in this element, there are stress distributions here. Okay, there are stress distributions here. So, class, these stress distributions, okay, these are caused by the bending moments M, okay, and M plus dm. So, class, if you are going to consider this element here, class, of course, no, there will be a moment na nag-a-act, no, internal bending moment, kumbaga, no, na nag-a-act dito sa element na ito. So, this is the internal bending moment at this side. Okay, and dun sa kabilang side naman, class, yung internal bending moment will be M plus dm. Wherein this dm, class, so this is the change or the infinitesimal change in moment or in m over the distance dx. Okay, so take note, class, that this is just a very, very small element. Okay, and kinuha natin yan dito sa beam na ito. And class, there's loadings here, di ba? Merong loadings, class, dito, no, na nag-a-act. Okay, so therefore class, no, as we go along the distance dx class, no, what happens is that merong nadadagdag na plus dm due to the distance, no, and dun sa loading na naka-apply, let's say, no, in this element. Okay, kaya meron ditong plus dm. Okay, so in this case, class, these moments, okay, these moments, class, these internal bending moments that act, no, in this element, class, this will cause, no, stress, no, sa ano natin dito sa element natin na to. Okay, so as we have talked about, no, in our discussion about flexural stress or bending stress, okay, so due to the bending moment, no, magkakaroon tayo ng stress, ng bending stress or flexural stress, no, doon sa cross section. Okay, so in this case, class, okay, so yung mga moments natin, class, dito, itong moment M and moment M plus dm. Okay, so this will cause a positive bending moment, di ba, for this element. Kasi, class, it will cause the element to smile. Pero dito kasi, class, since sobrang liit lang nito, kasi dx ito, hindi na natin siya makikita dito. No, but it will cause these moments, no, this M and this M plus dm, they will cause this element to have a positive bending moment. So, magi-smile yung element natin. So, kung magi-smile yung element natin, class, okay, so what happens is that yung parteng taas, it will be subjected to compression. Okay, so ito, class, yung representation nung compressive stress na mag-a-act doon sa upper part, no? Yan yung above the neutral axis. Let's say ito yung neutral axis. So, above this neutral axis, class, the stress will be compressive. Okay, kaya makikita mo dito, class, ganyan yung direction ng stress distribution natin dito. Okay? And ganun naman on the other hand, no, dito sa baba, class. Okay, so it will be subjected to tension. So yung stress distribution natin dito, it will pull away, no? It will pull away the cross section, kumbaga. Okay, so kaya pahila, no, yung stress distributions natin dito. Okay, so class, for this stress distributions, okay, we can resolve them, no, into their equivalent force. No, itong stress distribution na to, let's say ito yung equivalent force niya, dF double prime. Ganon din dito, class, sa baba, yung tensile stress na to. Let's say yung force niya, class, no, yung equivalent force niya ay ito, dF double prime din. So, dito naman, class, sa may stress distribution dito, compressive ito. So, ito yung equivalent niya na force. No, ganun din dito sa tensile stress na to. Ito yung equivalent tensile force niya. Okay? Ayan. So, class, itong mga forces na ito, okay, so these horizontal forces, okay, it should be in equilibrium. Okay, they should be in equilibrium. No? And kailangan nga masatisfy nila ito, class. Yung summation ng forces horizontal, they should be equal to 0. Okay, so we are going to use this, no, equilibrium equation, okay, to kumbaga solve this system para ma-derive natin, class, yung shear formula. Okay. Okay. Now, we consider the shaded top portion of the element that has been sectioned at y prime from the neutral axis as shown here. Okay, so let's say at distance y prime, okay, from the neutral axis, class, okay, and then we consider the area, no, above that point. Okay, so the area, class, will be this shaded portion. Okay, so let's say we consider this portion, class, this shaded portion. Okay, so because the resultant moments on each side of the element differ by dm, it can be seen in figure 7.4c that summation of fx equal to 0 will not be satisfied unless a longitudinal shear stress tau acts over the bottom face of the segment. Okay, so class, di ba kanina yung mga nag-a-act na moment, okay, doon sa element natin, class, they differ, no, by dm. So, ito yung ano nila class, yung difference nila class. So, kapag class ginamitan natin ito ng summation ng forces horizontal or Fx equal to 0, hindi siya magzi-zero. Kasi meron silang difference nga na dm. Okay, so in this case class, itong dm na ito class, it has to be opposed. No, there has to be a stress, no, na kailangan man-neutralize, okay, yung difference na dm, okay, na makakancel yung dm, okay, para maging equilibrium class, okay, yung system natin dito. So in this case class, okay, the stress, okay, that will neutralize, no, the dm difference here will be this shear stress. Okay, so as you can see here, no, this shear stress tau, so this acts, no, doon sa cross section doon sa ilalim. Okay, sa cross section dito class. Ayan, no, dito sa side na ito. Okay, doon sa ilalim class nung kinonsider natin na area. Okay. Okay, so in this case class, this shear stress tau, ito naman yung ano niya, representation kapag dito tayo nakaharap sa side na ito. Okay, so ito class yung nag-a-act na shear stress tau. Okay? Okay. So class, doon sa area, okay, or yung portion na kinonsider natin class, itong top portion na to, itong shaded na ito class. Okay. Okay, so class, yung stress dito sa side na ito class will be this stress, ano to due to the bending moment. Okay, so ito yung compressive stress dito sa part na ito. So ito class ay sigma. And then dun sa kabilang side class, okay, ito naman yung compressive stress class na nag-a-act. So this is sigma prime. Okay? Okay. So class dito sa portion na ito class na kinonsider natin, yung mga nag-a-act dito ay itong compressive stresses na to at saka itong shear stress tau na ito. Okay? So from here, we will assume this shear stress is constant across the width T of the bottom face. Okay? It acts on the area T dx. So it means class that the shearing area will be T dx. Okay, so that is T. So class yung T, that is the width, no? Ito class, itong width na ito class nung bottom face, no, nung portion na kinonsider natin. Okay, so ito yung ito yung width T. Okay, so again class yung shear stress natin na ito na tau, it will act dun sa shearing area T times dx. Okay, T times dx. So yun yung shearing area. Okay. Okay, so applying the equation of horizontal force equilibrium and using the Flexure formula, we have summation of forces horizontal or Fx equal to 0. So our assumption here, class, is positive for forces that are directed to the left. Okay, so from here, class, no, from this system, okay, so class, we are going to sum up the forces here. So for this stresses, class, we are going to solve, no, their equivalent force. No, from the formula for stress, no, we know that the formula for stress is force over area. So to solve for the equivalent force of this stress, so that will be force is equal to stress times area. So in this case, class, for this stress, so this is directed to the left, no, so it will be positive here. Okay, so it will be multiplied to the area where it acts. Okay, so in this case, class, let's say the area where this sigma prime, no, acts is dA prime. Okay, so the summation, class, no, of the stress here in this element, okay, on its differential area, class, okay, that will be the equivalent half force. Okay, so it will be positive nga, class, since this is directed to the left. Now for this stress, so we are going to solve its equivalent force. So its equivalent force will be force is equal to stress times area. So in this case, class, the equivalent force of this stress is sigma dA prime, and we are going to sum up, no, the stress, no, that acts in this differential area, kaya ito integral. Okay, kaya ito integration. Okay, so in this case, class, it will be negative since this is directed to the left. No, so this is directed to the right rather. So this is negative since this is directed to the right. And also class, for this shear stress, okay, so for this shear stress class, okay, so it will be negative also, and its equivalent of shear force, okay, it will be from our formula, right? Shear stress equal to shear force over area. So to solve for the equivalent shear force, that will just be shear stress times the area. Tama ba? Yeah, the area. So the area here, class, where this shear stress acts is TDX. No, so that is this. No, this area dx times t. This is the t. This is the width. Okay, doon sa bottom face, no, nung ano natin, nung kino-consider na top portion. Okay, so this is also negative, class, since this is directed to the right. Okay, so from here, class, if you are going to simplify this, okay, so class, for this stress, okay, so this stress sigma prime, okay, so take note, class, this sigma prime na stress, okay, so class, this is a compressive stress, no, and yung compressive stress na to, class, galing ito dun sa bending stress, no, so yung bending stress, class, di ba yung formula natin doon ay my over I. That's our formula, right, for flexure stress or bending stress. Okay, so for this compressive bending stress, class, okay, na sigma prime, yung formula natin dito, class, ay my over I. Wherein yung m natin dito, class, take note, class, na itong compressive bending stress na to, galing siya dito sa bending moment na m plus dm. So yung moment niya ay m plus dm and then y over I. Okay, times dA prime. Okay, also, class, for this stress, so this is the stress sigma. Okay, so our formula for this, class, is my over I, and the m that caused this compressive bending stress, class, is this m. Okay, so our formula here, class, will be my over I, okay, times dA prime. Okay, minus, okay, so we just rewrite this, no, tau times t dx equal to 0. So, simplifying this further, class, okay, so merong makakancel dito, class, yung m over I times y dA prime, it will be subtracted by m over I y dA prime also. So, what will remain here will just be dm over I times y dA prime, no, which is this term. Okay, and then this minus tau times t dx, it will be transposed to the other side, so it will become positive tau times t dx. So from here, class, if you're going to solve for this tau, shear stress tau, okay, so it will become, so this t dx, it will just be cross multiplied here. Okay, so what happens is that it will become 1 over it. Okay, so this t will be cross multiplied here, and then times dm over dx. So this dx will also be cross multiplied here. So this will become dm over dx times the integral of y dA prime. Okay, okay. Okay, so from this equation, class, we can simplify this further by noting that dm over dx, class, this is actually equal to v. So we talked about this in our discussion, no, about the graphical method, no, in constructing shear and moment diagrams, right? We already know, no, that v is equal to dm over dx, right? So we can rewrite this dm over dx as v. Okay, also, the integral represents the moment of the area A prime about the neutral axis. So, this integral, class, okay, so this area, this is the area, no? So, this is the area of the portion that we are considering. And then this y, this represents the moment arm, no? The moment arm, okay, of this area, okay, about the neutral axis. Okay, so, plus, this integral, okay, we can denote this by the symbol Q. Okay, this integral y dA prime, okay, we can denote this as Q. Okay, by that symbol. So, since the location of the centroid of the area A prime is determined from y bar prime is equal to integral of y dA prime over A prime. Okay, so class, you learned this, no, from your statics of rigid bodies, how to determine y bar, okay, or the y coordinate of a centroid, no. So class, yung naaalala mo siguro na formula is ay is equal to summation, okay, summation of ay, no, small letter ay, okay, isa-sum up mo yon, yung area or yung moment ng mga area, okay, wherein yung moment arm will be the corresponding y coordinate, no, nung mga area na isa-sum up mo. Okay? So, you learn this from your statics of rigid body. So, here class, no, we can also write yung Q, okay, na ito yung class, di ba? Yung integral of y dA prime. So, we can also rewrite this as y bar prime, okay, times A prime. Okay, so, dito natin yung nakuha class. Itong A prime, pwede nating i-cross multiply dito. So, it will become A prime y bar prime is equal to integral of y dA prime, wherein ito yun. No? So, ibig sabihin nga, yung Q natin class, it can be rewritten as y bar prime is equal times A prime. Wherein yung A prime class, yan yung area nitong area or itong portion na ito class na kino-consider natin. Itong area na to. Ito yung A prime. Okay, and yung y bar prime, class yan yung location ng centroid ng area natin, no, papunta dun sa neutral axis. Okay, so again, from the neutral axis to the centroid of the area na kino-consider natin, class, yun yung y bar prime, ha? Okay, so makikita mo rin yan dito. Ayan. So, from here, class, no, the final result, okay, from here, okay, we can rewrite, no, the formula for shear stress as this. Okay, yung dm over dx natin, class, that is V. Okay, and then ito, class, ito ay Q. No, so, nire-write natin siya as Q over IT. Okay, IT. Class here, no, ito na class, no, yung ano natin, yung shear formula or yung ginagamit nating formula to solve, no, for the shear or the shear stress. Okay, for the shear stress class doon sa point no, na kino-consider natin. In this case kasi class, yung point na kinonsider natin dito is y prime from the neutral axis. So, ito class yung mag-a-act. No, ito yung stress class. Ito yung shear stress na mag-a-act dito, no, sa ano na ito, dito sa point na ito. Okay, nung cross section natin. Okay. Okay, so finally, class, this is now the shear formula. So, this is tau is equal to VQ over IT. Okay, so class, in some textbooks, no, so this T, ang ginagamit na notation sa kanya ay B. So, pwede ring VQ over IB. So, that's just the same, ha? Okay, where tau here, class, this is the shear stress in the member at the point located at a distance y prime from the neutral axis. This stress is assumed to be constant and therefore average across the width T of the member. So, ito na class yun, no, yung shear stress natin. And take note, class, na from our derivation, actually, yung shear stress natin, ito class ay longitudinal shear stress. Right? Ito yung nag-a-act dito sa area na to sa ilalim. Pero, take note, class, ang longitudinal shear stress, equal din yan, class, sa transverse shear stress acting at that same point. So, in this case, class, no, yung makikita mo yung shear stress natin dito ay transverse. No? So, transverse ito, hindi ito yung longitudinal. Pero, equal kasi sila. Okay? Okay. So, also, class, for V, so this is the internal resultant shear force determined from the method of sections and the equations of equilibrium. So, ito, class, yung nag-a-act na shear force dun sa kino-consider natin na cross-section. Okay? And then I, class, this is the moment of inertia of the entire cross-sectional area calculated about the neutral axis. Okay, so our reference axis here is the neutral axis, ha? Okay, so we solve the moment of inertia, okay, about this axis, about the neutral axis. Okay, and then for T, so this is the width of the member's cross-sectional area measured at the point where the shear stress is to be determined. Okay, so class, ito class yung width na ito, ha? No? Ito yung width ng pinaka-bottom nung area na kino-consider natin, ha? Okay, so yan yung width Okay, yan yung width T. Okay, so sa ibang textbook, ulitin ko class, ito ay D. No? So that's just the same. No, yun yung base, okay, or yung width nung bottom face nung ano natin, nung kino-consider natin na area. Okay. Okay, and then Q here class. Okay, so this is y bar prime times a prime, where a prime, this is the area of the top or bottom portion of the member's cross-sectional area. Okay, above or below the section plane where T is measured, and y bar prime, this is the distance from the neutral axis to the centroid of A prime. Okay, so class, if the point that we are kung saan yung point of analysis natin ng shear stress, let's say at this point nga, so class, automatic, yung area na i-consider natin is yung area above that point. Actually, pwede rin natin gamitin yung area below. Okay, so it depends on the problem kung ano yung mas madali na gamitin. So, pwede mong gamitin yung area above or area below. So, in this case, let's say yung point na kino-consider natin class is dito sa point na to. Okay, yung kung gusto nating kuhanan ng shear stress. Okay, so dito sa point na to class, yung i-consider nating area is yung area above. Okay, so area, para mas madali yung computation natin. Okay, and then, yun yung ano ha, yung area prime class or yung A prime, ito yung area na ito. Yung area ng cross-section na to. Okay, nung kino-consider natin. Okay, yun yung A prime ha. And then class, yung Y bar prime. Yung Y bar prime class, yan yung centroid. Okay, yung distance. Okay, ulitin ko. Yan yung distance from the neutral axis to the centroid ng A prime. Okay? So, take note of this class ha. So, it's important na alam mo class kung ano ito yung laman ng formula natin. So, again, yung V, ito yung shear force doon sa section na kino-consider natin. Yung Q natin class, yan yung, ito class, tinatawag din itong first moment of area. Okay? First moment of the area na kino-consider natin. Okay, so yan class ay y bar prime times a prime ha. And then yung I natin, yan yung moment of inertia na kinukuha natin about the neutral axis. And then yung T natin class, that is the width or the width of the base ng area na kino-consider natin ha. Okay. Okay. Okay, so the above equation is referred to as the shear formula, although in the derivation we considered only the shear stresses acting on the beam's longitudinal plane. The formula applies as well for finding the transverse shear stress on the beam's cross-section. Recall that these stresses are complementary and numerically equal. So class, wag kang malilito. Okay, let's say sa mga problem class na ibibigay, ang tinatanong is yung transverse shear stress. Okay, so ito rin yung formula na gagamitin natin. Okay, or kung yung sabihin is longitudinal shear stress. So ito rin class yung gagamitin nating formula. Kasi nga class, yung transverse shear stress at saka yung longitudinal shear stress, they are just equal. Okay, sa ibang terms naman class, okay, yung transverse shear stress, yun yung vertical shear stress. Okay, and doon naman sa longitudinal shear stress, yun naman yung horizontal shear stress. Okay, so same lang yung mga yun, class, ha? So, ito lang din yung i-apply natin na formula for both cases. Okay? Okay. So, also, because the Flexure formula was used in the derivation, it is necessary that the material behave in a linear elastic manner and have a modulus of elasticity that is the same in tension as it is in compression. Okay. Okay, so we are now going to summarize our procedure for analysis of shear stress. The following procedure can be used to determine the shear stress at a given point in a beam. So our first step, we are going to use equilibrium analysis to determine the vertical shear force V acting on the cross-section containing the specified point. So the construction of a shear force diagram is usually a good idea. So syempre class, yung gagamitin nating shear force dito is yung shear force na nag-a-act doon sa point, no, doon sa beam na kino-consider natin, ha? Okay. And then, our second step, we have to locate the neutral axis. So, may mga cases, class, na it's not indicated, no, in the given cross-section, yung neutral axis. So, we have to locate it. And take note, class, na yung neutral axis, it is located in the x-centroidal axis. no? And yung excentroidal axis class, no, pwede mo yun ma-solve, no, if you solve for the centroid of the cross section. Of course, yung centroid natin, yung point ng centroid natin, nandun yung excentroidal axis. Doon nagpa-pass through yung excentroidal axis. So you have to know, you have to have knowledge about that, which is yun na pag-aralan mo na sa statics of rigid bodies. And also class, compute the moment of inertia of the cross-sectional area about the neutral axis. So, yung pag-solve class ng moment of inertia, natutunan mo na nga ito ha sa statics. So, i-apply na lang natin siya dito. And take note class ha, na yung moment of inertia natin na kinukuha dito is about the neutral axis. Okay, so for our third step, we are going to compute the first moment Q of the cross-sectional area that lies above or below the specified point. So, pwede nating i-consider yung area above dun sa specified point or pwede rin naman yung below. Okay, pwede rin yon. So, it depends dun sa problem kung ano yung mas madali na i-consider, no? Na mas mapapadali yung computation natin. But anyway, yung fourth step natin, class, calculate the shear stress from the formula VQ over IT, where T, this is the width of the cross-section at the specified point. Note that tau is the actual shear stress only if it is uniform across T. Otherwise, tau should be viewed as the average shear stress. Okay. Okay, now for maximum shear stress, the maximum shear stress, tau sub max on a given cross-section occurs where Q over T is larger. So take note class, ang formula natin, di ba, for stress ay VQ over IT. Class, yung V natin, constant yan. Di ba, constant yan all throughout the cross-section. Kahit sa ang point ng cross-section yung i-consider mo, constant yung V. Yung I, yung moment of inertia, constant din siya. 'Di ba? Kasi yun yung moment of inertia nung buong cross-section class eh. 'Di ba? About the neutral axis. So, constant yung V at saka yung I. No, ngayon, yung magva-vary lang class is yung Q at saka T. Okay, so para malaman natin yung maximum shear stress, dapat yan yung, kumbaga, largest yung magiging Q over T. Okay, so kailan ba class magiging largest yung Q over T? So of course, magiging largest yung Q over T kapag malaki, no, yung value, no, kung mataas yung value class ng Q. Eh kailan ba class nagiging mataas class yung value ng Q? Okay, so let's say class na yung width T is constant. Okay, dun sa cross section nung beam natin, no? Then tau max occurs at the neutral axis because that is where Q has its maximum value. Plus magiging maximum yung value ng Q, no? Kapag nasa neutral axis yung point na kino-consider natin. Kasi class, 'di ba, kung dun yung point na kino-consider natin, dun sa neutral axis. So i-consider mo ng buo yung area above or below. So yun yung magkakaroon ng pinakamalaking area. Tama? Tama, yun yung magkakaroon ng pinakamalaking area class. Therefore, doon magkakaroon ng pinakamalaking value ng Q, ng first moment of area Q. Okay, so however class, kung yung T naman ay hindi constant, okay, so it is necessary to compute the shear stress at more than one point in order to determine its maximum value. Kasi class, di ba, Q over T, no? Let's say nga yung T hindi siya constant. Okay, yung width T natin hindi siya constant. So ito para to sa mga cases na non-rectangular, no? Pero kung ganito class, kung rectangular yan, matic, na yung maximum shear stress niya nasa neutral axis. Pero kung hindi yan rectangular, okay, and hindi rin yan, kumbaga, symmetrical na I-shape section, okay, so yung mangyayari class, it is necessary na maghanap ka ng point, okay, na hahanapan mo rin ng shear stress, tapos i-compare mo yung mako-compute mong stress doon kung ano yung mas malaki. Kung yung stress ba na na-compute mo doon sa neutral axis or yung stress na na-compute mo doon sa point. Okay, so class, yung point na napipiliin mo dito class, okay, is yung point na yung point class na mas maliit, no, yung width T. Kasi class, kung mas maliit yung width T, no, doon sa point na yun class, lalaki yung Q over T. 'Di ba? Q over T, kapag maliit class yung T, 'di ba? Lumalaki yung value ng Q over T. Tama? Tama? the more na nagiging maliit yung value ng t. So, hahanap ka class nung point, no, na yung t class ay maliit. Okay? So, yun yung i-consider mo, and then i-compute mo yung stress doon. And again, class, i-compute mo yung stress na nakuha mo doon sa stress na nakuha mo sa neutral axis. And kung ano man, class, yung mas malaking value, okay, yun yung magiging maximum shear stress. So, mamaya may problem naman tayo na ganito. So, may ipapakita natin yan. Okay. So, class, for rectangular cross-section, so as I've mentioned earlier, matic class na yung maximum shear stress niya, it is at the neutral axis. Okay? And actually, class, yung shear stress dito sa neutral axis, no? So, yung derived formula para dun, class, ay 3/2 times V over A. Okay, wherein yung V class, ito yung shear force na nag-act dito sa section na to. And then yung A class is yung cross-sectional area nung buong, nung buong cross-section. Okay, so class, ito ay, derived formula na. Pero class, actually, itong derived formula na to, na-solve din ito by using the procedure na diniscuss natin on the previous slide. No, yung VQ over IT. No, so, pwede mo rin siyang gamitin. So, same lang din yung lalabas na result as this. Okay, so again, class, yung maximum shear stress for rectangular cross-section, nasa neutral axis siya, ha? Okay, so nandun siya, dun mo siya makikita. And class, mapapansin mo, baligtad dito. Diba, class, sa moment, no, sa bending moment, class, yung maximum bending stress, diba, nandun sa outermost surface nung beam natin, nandito sa dulo. Diba, nandito yung maximum. But in this case, class, for shear, no, yung maximum natin, no, pero case to case ito, ha. For rectangular class, yung maximum natin nandito sa neutral axis. Okay, so nagme-make sense yun sa'yo, ha. Okay, anyway. So class, for for wide flange beam, so ganito yung wide flange beam. Okay, so yan ay parang I shape. Okay, so most of the bending moment is carried by the flanges, whereas the web resists the bulk of the vertical shear force. Okay, so yun yung binanggit ko kanina, ha. So kung bending moment yan, class, yung pinaka mai-stress is yung upper portion at saka lower portion, 'di ba? No, pero sa shear stress, class, okay, yung mai-stress dito, class, is yung bandang gitna. So in this case, class, kung ito ay wide flange beam, okay, itong flanges natin, class, no, ito, class, yung magre-resist doon sa bending moment. Pero ito naman, class, web, etong web natin, class, ito naman yung magre-resist doon sa shear force. Okay, okay. So, the maximum shear stress in the web is at the neutral axis. So, class, kung I-section tayo, tapos, tayo dito, let's say, itong width nung web natin, class, or yung thickness nung web natin, class, ay constant naman. Okay, so yung maximum shear stress din natin dito, class, ay nasa neutral axis. Okay, nasa neutral axis din siya, class. Okay, so, class, however, yung minimum naman na shear stress, okay, yung minimum shear stress natin, class, in the web, okay, so let's say in the web, it is at the junction with the flange. Okay, so yung class, yung junction nung web at flange ay nandito, kung saan sila konektado. So, nandito yung minimum shear stress. Okay, for the web, ha. Okay, and yung maximum shear stress, class, again, nandito sa for the web, ha, nandito sa neutral axis ng web natin. Okay. So, class, for the shear force carried by the web, ayan, kasi nga, class, yung malaking portion nung shear force natin, class, dito talaga siya sa web mapupunta. Kasi nga, itong itong flanges natin, wala itong capacity, class, no, or napakaliit lang nung capacity niya, no, para mag-carry ng shear force. So, yung magke-carry talaga ng shear force, class, ay itong web. Okay, so, class, yung shear force na carried by the web, no, pwede natin siyang ma-solve using this formula. So, ito yung shear force carried by the web, or V sub web, is equal to the product of the cross-sectional area nung web natin, no, and the area of the shear stress distribution. Okay, so class, ganito, pag-usapan natin yung shear stress distribution, no? So class, for rectangular cross-section, okay, as I've mentioned kanina, yung maximum shear stress niya, class, nandito sa neutral axis. So, kung ano natin, class, ipa-plot natin, no? So, let's say this is the shear stress distribution, class. Okay, nung ano natin, itong rectangular cross-section na to. Okay, so dito, class, sa may point, dito sa neutral axis, ito yun, di ba? Yung neutral axis. So, dito maximum, class, yung shear stress. Okay, so itong stress dito sa point na to, class, ay 3 over 2 VA. Or 3 over 2 times V over A. Ito dito sa point na to, dito siya maximum. And dito, class, sa point na to, which is nandito na yan sa uppermost, no, dito sa pinaka outermost surface nung beam natin. Class, 0 yung ano dyan, shear dito. 0 yung magiging shear dito. Ganon din dito sa baba, yung pinaka outermost surface niya, 0 yung magiging shear dyan. Bakit, class? Kasi, class, di ba, kung i-compute natin yung shear stress dito, di ba, class, anong area yung i-consider mo? Eh, di ba yung area na i-consider mo dyan is yung area above the point na kino-consider natin. So, kung nandito yung point na kino-consider natin, yung area, class, ay wala, 0. And on the other hand, class, kung yung below naman, yung i-consider natin, let's say, we consider, or we are going to solve the shear stress at this point. So, kung yung area below yung i-consider natin, pwede naman. Pero yung mangyayari, class, yung Q, magzi-0. Diba? Kasi, class, yung distance from the centroid nung, ano natin, itong area na to, na i-consider natin, nandun siya mismo sa yung distance niya, no, nung centroid niya, doon sa neutral axis, nasa same point sila. So, yung distance, class, will be 0. So, yung Q natin, therefore, magzi-0 siya. Okay, kaya 0, class, no, yung shear stress natin dito, tsaka dito. Okay, okay. So, ito, class, yung magiging, shear stress distribution for rectangular cross-section. So, ito, class, parabolic to, itong curve na to. Okay, so this is parabolic. Okay, now for this wide flange naman, class, yung magiging stress distribution dito. So, class, yung dito sa may natin, sa may flanges natin, no? So, actually, meron namang kaunting shear na i-carry, pero sobrang liit lang. And complicated din, class, no? Medyo complicated, class, yung magiging computation ng shear, no? Kapag yung i-compute natin is yung shear dito sa flange. Kaya, class, dito, ang i-compute lang natin is yung shear dito sa web. Okay, ngayon, class, yung stress distribution dito sa web, class. Okay, so dito sa junction niya, no, yung junction ng flange or yung connection ng flange at saka ng web. Okay, so i-compute natin yung shear stress dito, class. So, sa madaling sabi, yung area na mako-consider dyan is yung, diba, yung flange din. No, but anyway, we can compute that. And yung magiging shear stress dyan, class, ito yon yung magiging niya, distribution niya. Okay? And then, yung magiging maximum, class, no, na shear stress dito will be at the neutral axis. Kaya dito, class, makita mo, siya, dito siya maximum. So, ito, class, from here, no, to here, parabolic yan. No, so nandito yung yung maximum na shear stress nasa neutral axis. However, class, no, makikita mo dito na lang, sobrang liit lang din nung kumbaga pagbabago, no, nung shear stress dito at saka shear stress sa neutral axis, no. Yung shear stress dito sa sa may junction, no, hanggang dito sa may shear stress sa neutral axis. Medyo lang, gradual yung niya, no, pag-increase. Okay. Okay. So, ito rin, class, ay parabolic ito. Itong curve na to, ito ay parabolic din. Okay. Okay. Ayan. So, the shear stress distributions, class, are parabolic, ha? Okay. Okay, so let's start solving sample problems here. Okay, so for sample problem number 1, the simply supported wood beam in the figure is fabricated by gluing together 3 160 mm by 80 mm planks as shown. Calculate the maximum shear stress in, the first one is at the glue, no? So, dito yon yung glued portion natin. So, dito ginlu, no, yung wood beams natin. Okay, and then, and the maximum shear stress in the wood mismo. Okay, doon sa kabuuan ng natin, nung wood beam natin. Okay, so let's solve this problem, class. Okay, so again, for this problem, we are going to solve the maximum shear stress in the glue. So, ito yung, class, yung glue natin. And makikita mo, class, na itong glued, natin, portions, no, ano naman sila, same sila, no, symmetric yung location nila from the neutral axis. So, yung distance from the neutral axis to the glued portion dito sa taas, equal lang din siya dito. So, kahit isa lang yung i-consider natin dito, no, dun sa glued portion ng beam natin. Okay, so, okay. So, to solve this class, okay, so we are going to start, no, dun sa maximum shear stress in the glue. So, class, yung distance y natin dito, class, ito yon. Okay, so, ibig sabihin, class, ano yun, no, kalahati ng 80 mm. So, 40 mm, class, yung distance y natin. So, from the neutral axis, no, 40 mm, no, from the neutral axis will be, ito yun nga, yung glue. No, so, ibig sabihin, class, yung area na i-consider natin dito is yung area above that specified point. Okay? So, the specified point, again, class, is 40 mm from the neutral axis. So, yung area above, yung i-consider natin. Actually, pwede rin i-consider yung baba, ha? But anyway, ang consider na lang natin is yung nasa taas para mas madali yung computation natin. So, we are going to follow our procedure here, class. So, yung first step natin, we have to solve the shear. Okay, the corresponding shear force. Okay, na gagamitin natin dun sa formula natin. So, in this case, class, since the question is maximum shear stress, so we have to use the maximum shear force. Okay, dun sa magiging shear diagram natin, shear force diagram natin. So, kailangan muna nating isolve yung reaction forces dito. So, in this case kasi, class, ipinakita naman na dito, no, kung ano yung value ng reaction force dito sa A at saka sa B. But, if you are going to solve that, okay, we can take moment here at B, and then we can solve for the reaction here. So, it will just be R sub A times 6 minus A times 6 times 3 is equal to 0. So, solving for the reaction at A, so that will be 24 kilonewton. And we can sum up forces vertical here, no, to solve for the reaction here at B. So, that will just be R sub A minus A times 6 plus R sub B is equal to 0. Yung R sub A natin, 24 na yan. So, yung R sub B natin ay 24 kilonewton. So, yan na yung mga reaction. So, if you're going to draw, no, the shear diagram, okay, so at this point, class, our shear force ay 24 kilonewton na pataas. So, it will be positive here. So, the 24 kilonewton shear force will be here. And then, dito naman, class, sa point B, yung shear force natin, class, okay, will be negative 24. Kasi, class, no, ang mangyayari, 24, no, minus the area under the loading. So, the area under the loading, class, ay 8 times 6, diba? So, it will be 24 minus 8 times 6. That's, so, it will become negative 24 here. And ito, class, yung value ng negative 24, yung shear natin dito, okay, so, yung absolute value nito, class, it should be equal dun sa absolute value nung ano natin, nung reaction din dito sa point B, which is 24 naman siya. So, magko-close din ito, itong ano natin, shear diagram natin. So, we can say na tama naman. No, ito. And, class, itong ano natin, itong dalawang point na to, it will just be connected by a straight line. No, kasi rectangular lang yung ano natin eh, yung load natin. So, yung shear natin, ano lang yan, triangle lang yan. So, itong straight line na to, 1 degree to, 1 degree curve. No, itong straight line na ito. Anyway, so, class, malinaw na malinaw dito sa ano natin, shear diagram natin, na yung maximum shear force natin is 24. So, regardless of the ano no, of the sign. So, yung magiging maximum shear force natin ay 24 kilonewton. At yung mga maximum shear force natin, class, no, nag-a-act siya sa supports. No, so, nandito pala, class, yung maximum shear force, no, for this beam, nasa supports. Okay. Okay. So, from here, class, we will now proceed dun sa second step natin. Yung second step natin, class, we are going to locate the neutral axis. But in this case, class, it's already indicated, no, in the given cross-section, yung neutral axis. So, yung neutral axis natin, nandito lang naman. And rectangular siya. So, alam natin agad na nasa gitna lang siya. Diba? Nasa gitna lang siya, class, yung neutral axis natin. So, the neutral axis is the axis of the symmetry, of the cross-section. So, axis of symmetry siya kasi yung nasa taas na area, diba, symmetric lang din dun sa area na nasa baba ng neutral axis. Okay, yung next step natin, class, so actually nasa second step pa rin tayo. We have to compute the moment of inertia. So for this cross-section, this is rectangular cross-section. So yung moment of inertia natin, we will compute that about the neutral axis. So ito, class, ay moment of inertia about the x centroidal axis. So yung formula natin dun, class, ay bh cube over 12. Okay, wherein yung base natin ay 160 mm, yung height natin ito, 80 plus 80 plus 80, yun ay 240, di ba? So, substituting those values here, so it will become 160 times 240 cube over 12. Okay, so solving for I, it will be 184.32 times 10 raised to 6 millimeter to the fourth. So, ito na, class, yung moment of inertia natin. Okay, so yung next step natin, class, we are going to compute the first moment of area Q. So again, class, yung first moment of area Q, ito yung ano natin, formula. Yung ito ay A prime times Y bar prime, wherein yung A prime, class, ito yung area na above, no, or below dun sa point na in-specify. So in this case kasi, class, di ba, yung sinosolve natin is ito, yung shear dito sa glue portion. So, class, in this case, yung area na i-consider natin is yung area above. No? Pero pwede rin, again, class, yung area below. Pero mas madali kasi, class, yung area above. So, yung area above, class, is ito, yung area na to, 80, tapos itong base ay 160 din. Okay? So, yun yung A prime. No? Yun yung A prime natin. 180 or 80, no, times 160, yun yung area. No? So, since rectangle yan, base times height, 160 times 80. Tapos, class, yung y bar prime natin, ito, class, yung distance, okay, nung centroid nung A prime, okay, papunta dun sa neutral axis. Yun yung distance. Okay, so in this case, class, alam din naman natin agad kung nasan yung centroid, no, nitong, ano natin, A prime natin. No, alam natin, nasa gitna lang. So, ito ay 40 mm lang dito. Okay, from the glue, no, 40 mm yung distance niya dun sa centroid. So, isasama pa natin tong distance na to. Kasi ang kailangan natin, yung distance from the neutral axis, dun sa papunta dun sa centroid. Okay, para dun sa y bar prime. Okay, so substitute natin. So, yung area prime natin, yan ay 160 times 80. Okay, and then yung y bar prime natin, class, so yung distance ng neutral axis papunta dun sa glue, 40. Tapos from the glue, papunta dun sa centroid, 40 din, di ba? So, yan ay 40 plus 40. Okay, so therefore, class, yung Q natin ay 1.024 times 10 raised to 6 millimeter cube. Okay. Okay, for our next step, we can now calculate the maximum shear stress, no, in the glue by using this formula. So, this is tau sub max is equal to, this is just VQ over IT, VQ over IT. So, yung V natin, class, yan yung maximum shear force, no, na nakuha natin from the shear diagram. So, yun ay 24 kilonewton, so 24,000 newton. And then, our Q is 1.024 times 10 raised to 6 millimeter cube. And then, our I, so this is 184.32 times 10 raised to 6 millimeter to the fourth. And our T, class, our T, no, so that is the width, no, nitong ano natin, yung bottom face nung ano natin, nung A1. Okay, so ito yon yung T, which is 160 mm lang din. Okay? Okay, so from here, no, the maximum shear stress, class, no, at the glued section, no, of our beam is 0.833 megapascal. So this will now be the answer for the first part, no, for letter A. Now for letter B, class, for the maximum shear stress in the wood, okay, so same formula, no, VQ over IB. So yung V natin, it will just be the same. That is still 24,000 Newton or 24 kilonewton. And yung I natin, it will also be the same. So yung mag-iiba lang dito, class, is yung Q at saka yung T actually, since yung width naman natin dito nung cross-section natin ay constant. So hindi rin siya magbabago. So yung magbabago lang dito is yung Q. So let's solve for the Q. No, and class, take note na yung maximum shear in the wood, no, dito sa buong cross-section natin, yung maximum, class, mangyayari dito sa neutral axis. Okay, so we already talked about that kasi nga, ano to, rectangular cross-section. So, matic, yung maximum shear stress, mag-a-occur sa neutral axis. Okay, so here class, no, we can use two solutions since ito ay rectangle. Yung solution 1 natin, ito yung normal na pagso-solve natin, VQ over IT. And then yung solution 2 class, yun yung ano na, yung derived formula, yung 3 over 2, V over A, no? So, mamaya gamitin natin. So, yung solution 1 muna tayo. So, para dun sa usual na pagsosolve, which is VQ over IT. So, again, class, yung Q lang yung magbabago, no? So, solve natin yung first moment of area Q. So, nasa neutral axis na class yung point na kino-consider natin. So, therefore, class, yung A1 natin will be the area above or below. So, kahit ano gamitin mo dyan, above or below, same lang kasi symmetrical yan. So, let's say, ito class yung kinonsider natin, itong nasa itaas. So, ito yung area na i-consider natin. So, this will be A1, A prime. Okay, so, this will be A prime. So, yung A prime natin, yan ay 80 to, no? Yung height 80 plus 40, kalahati ng 80. So, 120, tapos yung base niya, 160 pa din. Okay, so, that will be 160 times 120, yung A prime. Okay, ngayon, para dun sa y bar prime, so yung centroid class nitong A1 natin will just be, nasa gitna ng 120. Kasi 120 tong height na to eh. Diba? Yung nung A prime natin, yung height ay 120. So, yung y bar prime natin kalahati nun, no, 60. So, that will be 60. Okay, so solving for Q, that is 1.152 times 10 raised to 6 millimeter cube. Okay, so solving now for the maximum shear stress in the wood. Ito na yung formula natin, class. So, again, yung nagbago lang dito, class, is yung Q. No, yung V maximum shear force natin, it's just the same, 24,000. Yung moment of inertia I natin, it's just the same. And then yung T natin, it's just the same since constant nga lang din, no, yung width nung cross-section natin. So, solving for the maximum shear stress in the wood, class, this is 0.9375 mega Pascal. And class, kung i-compare natin, no, yung value nung nandito sa glue, sobrang liit lang din, di ba, nung difference nila. No, so, hindi nagkakalayo yung ano nila, yung values nila din. No? And class, you have to check your answer kung logical yan. So, in this case, mas malaki class yung shear stress dito sa neutral axis, dapat, no, kesa dito, sa shear stress dito sa glue na to. No, so, in this case, logical naman yung naging sagot natin. Mas malaki talaga yung shear stress, no, dito sa neutral axis. Okay. Now, we can also use the class, the solution 2. So, yung solution 2 class, so since this is rectangular, we can use this formula, no, for maximum shear stress. This is equal to 3 over 2 V over A. So, yung V natin class ay 24,000 Newton. And then, yung area natin, class, yung A dito, class, yung area ng buong cross-section, ha? So, that will be 160, tapos yung height ay 240. Okay, so solving this, class, this is just also 0.9375 megapascal. Okay, so this will now be the answers, class, for this problem. Okay, now for sample problem number 2, the W12 by 40 section in the figure is used as a beam. No, if the vertical shear force acting at a certain section of the beam is 16 kips, determine the following at the section. No, the minimum shear stress in the web, the maximum shear stress in the web, and the percentage of the shear force that is carried by the web. So class, dito sa problem na to, no, so there's a given table, no, for the property, no, for the given wide flange section. Okay, so let's solve this problem, class. Okay, so class, to solve this problem, no, the shear force, no, is given in the problem. So the shear force, class, given is 16 kips. So this is the shear force that acts dun sa in-specify na point kung saan isosolve natin yung stress. Okay. And then, class, the dimensions of W12 by 40 section were obtained from table B6. So, illustrate lang natin, class, no, yung I section natin or yung wide flange section natin. So, class, from the table, okay, for W12 by 40, ito yon W12 by 40. Okay? So, class yung depth niya, ito yun, 11.9. 11.9 inch. So, ito yung class yung depth, yung total height, no, nung ano natin, wide flange section natin. So, ito class ay measured mula dun sa dulo, no, nung flange natin sa taas, hanggang dun sa dulo nung flange natin dito sa baba. So, ito class ay 11.9 inch. Okay, inch yan na yung dimension natin. Okay, and then yung width class nung nitong flange natin, okay, ito yung flange class, yung width niya ay 8.01. Inch din yan, 8.01 class, ito yon. And then, binigay din dito yung thickness, no, nung ano natin, nung flange natin, 0.515. So, yung thickness nito, so same lang din yan sa thickness dito sa taas. So, ito class ay 0.515 ha, yung thickness ng flange. And then, for the thickness of the web, so ito yung web, di ba? Yung thickness ng web natin ay 0.295. So, ito yung class, yung thickness na to. 0.295 inch. Okay, what else? Yun lang naman yung kailangan natin, no? Dito. Okay, so from here, class, no, our neutral axis will just be here. So, nasa ano rin ito, class, nasa axis of symmetry din ito nung ano natin, nung wide flange section natin, since yung area dito sa taas, symmetric lang din dito sa area sa baba ng neutral axis. No, so, yung neutral axis niya nandito lang din sa gitna. Okay, nung wide flange section natin. Okay, so from here, we will follow our procedure. Ano ba yung procedure natin, class? So, meron na tayong shear force. Okay, and yung neutral axis na alam na rin natin na nandito. Plus, yung moment of inertia, okay, actually, nandito na siya sa table. So, ito yung class, no, yung, ano, yung para dito sa table na to. Ito yung orientation nung, ano natin, nung wide flange section natin. So, ito class yung neutral axis, no? Itong x-centroidal axis na to. Okay, so class yung moment of inertia about the neutral axis, which is here at xx. Okay, so naka-indicate na rin dito class yung moment of inertia niya. So, ito yung moment of inertia. So, the moment of inertia about the neutral axis class, no, of W12 by 40 ay 307 inches to the fourth. Okay, so nakalagay na siya dito. Okay, so proceed tayo to our next step. So our next step, we have to compute the first moment Q of the cross-sectional area, no, that lies above or below, no, the cross-sectional area or above the specified point rather. Okay, so class, the first one that we're going to solve kasi is shear stress in the web. Or minimum shear stress in the web. And we already talked about this class, na yung minimum shear stress class sa web, it will happen dito. Okay, sa junction, no, nung flange natin at saka ng web natin, dun sa connection nila dito. So, nandito yung minimum shear stress natin class sa web. Okay, so, andito yung specified point natin therefore. So, therefore, class, yung A1 na i-consider natin dito class is yung flange. No, yung area ng flange. Okay, so yun yung area 1 natin. Okay, so yung Q over T dito class will be the smallest. Okay, magiging smallest siya class kasi yung area dito class ay ano lang, maliit. Magiging maliit yung area. No? Kasi ano siya, yan ay yung area natin na i-consider ito lang. 'Di ba? Yung flange lang. So yan yung magbibigay ng smallest na value ng Q. Okay. So, to solve for you Q class, okay, for the first moment of area Q, okay, yung kailangan natin is yung A, in this case class, let's say na itong area ng flange ay area 1 prime. Okay? Ayan. And then, yung distance from the neutral axis papunta dun sa centroid ng A1 prime natin ay Y bar prime. Okay, so ito yung Q na kailangan natin, class. Okay, so yung A1 prime natin, class, yan yung area nung flange. No, itong flange na to. So ano yung area nung flange natin, class? Yan ay 8.01 yung base, tas yung height, which is yung thickness, 0.515. And then yung Y bar 1 prime natin, class, ito yon, from the neutral axis to the centroid ng A1 prime natin. So yan class ay, ano ba itong distance na to? Okay, so kalahati ng 11.9 class, 'di ba? Ito, mula dito sa taas, pinakataas ng flange hanggang dito sa neutral axis. So 11.9 over 2. So kailangan pa natin i-subtract yung kalahati ng flange. No, yung kalahati ng thickness ng flange kasi centroid eh, 'di ba? So that will be 0.515 over 2. So it will become 11.9 minus 0.515 over 2. Okay, so solving for Q class, it will be 23.48 inches cube. Okay, so this will be the Q, ha? Okay, so we can now solve the minimum shear stress class in the web, okay, using our formula. So our formula here class will be VQ over IT. So yung V natin given na siya, 16 kips. And then our Q is 23.84 inches cube. And then our I is 307 inches to the fourth. And our T, yung T natin class ay constant. Yung web natin constant. Okay, so yan ay 0.295 inch. Okay, so from here class, okay, again class, yung T natin ha, ito yun. Okay, andito yun. Nandito yung class, yung T na i-consider natin dito class is yung ano ha, yung nandito class sa may connection ng flange at web. Ito yung width dito, which is yung width lang din naman nung web, no, which is 0.295. Okay. So, again class, yung minimum shear stress natin in the web ay equal sa 4.148 KSI. So, this is already the answer for letter A. Okay, now for letter B, we are going to solve the maximum shear stress in the web. And the maximum shear stress class, it is located at the neutral axis. Okay, this is where Q over T is largest. So, Q over T will be largest kasi class 4Q, di ba? Yung area class na gagamitin doon will be the whole area, no, above or below the neutral axis, which is yan yung instance na pinakamalaki yung magiging area. Okay, so what happens here class, no, yung V natin, class, it will just be constant, diba? Kung ano yung V na ginamit natin from letter A, yun lang din yung gagamitin natin dito. Yung Q, yun yung magbabago. Yung I, hindi rin siya magbabago. And yung T, hindi rin siya magbabago since yung thickness nung web natin, which is yun yung magiging T, diba? Constant din siya dito. Okay, so isa-solve natin, class, yung Q. The first moment of area Q. Okay, so in this case, class, since our area will be this area and this area, no? So, yan yung kabuuan ng area na gagamitin natin, class, for Q. Okay, so, ano na lang natin, class, no? I-solve na lang natin sila individually, tapos isa-sum up natin sila. No? Yung para dito sa, let's say, area na to, which is ito lang din yung ginamit natin kanina, yung para sa flange. No? So, ito, yung area nito, times yung distance ng centroid niya papunta dun sa neutral axis. Tapos, isa-sum up natin din yung Q nitong area naman na to, which is A2 prime. So, for the A2 prime, its Q will be yung area niya, which is A2 prime, times the distance ng centroid niya papunta dun sa neutral axis, which is Y bar sub 2 prime. Okay, so isa-sum up lang natin sila, class, to solve for the Q. So, Q, therefore, here, class, no? So, yung area 1 prime natin, so yan lang din yung kanina, 8.01 times 0.515. And then, yung Y bar sub 1 prime natin ay 11.9 over 2 minus 0.515 over 2. So, ito lang din yung kanina. Tapos, para naman dito, class, sa area 2 prime. So, yung area 2 prime, class, okay, so, ito yung area 2 prime. Okay, so ito ay rectangle lang din. So, yung base niya ay 0.295, no? And yung height niya, yung height nito, balik, class, ay kalahati ng 11.9, no? Kalahati ng 11.9 minus itong width ng flange or yung thickness ng flange. Tama? So, that will be para dito sa height na to. Kasi kailangan natin siya dun sa area, di ba? So, yung base ay 0.295 and then yung height ay 11.9 over 2 minus 0.515. Ito yon, no, para dun sa 8 sub 2 prime. Now, for the Y bar sub 2 prime, so yung distance nung centroid niya papunta dun sa neutral axis. So, ito class ay yung kanina lang, di ba? Yung 11.9 over 2 minus 0.515. Kalahatiin mo lang yon. Di ba? Yun ngayon yung magiging y sub 2 bar prime, which is ito yon. 1/2 nung height na to. Okay, so ito yon. So, solving for Q class, so it will be 27.83 inches cube. So, we can now solve class, no, the maximum shear stress in the web. Okay, so the maximum shear stress will be VQ over IT. Yung V natin, 16. Yung Q natin, 27.83 inches cube. Yung I natin, the same, 307 inches to the fourth. Yung T natin, so yung T naman natin dito, class, it's the same lang din, 0.295 inch. Okay, so solving for the maximum shear stress, so this is 4.917 KSI. Okay, so this will now be the answer. Okay, so for letter C class, no, we are going to solve the percentage of the shear stress that is carried by the web. Okay, so class yung shear force kasi natin dito, yung total ay 16 kips, di ba? So aalamin natin class kung ano yung percentage, no, from that 16 kips na kine-carry nitong buong cross section natin. No, titingnan natin kung ilan yung percentage na kine-carry nung nung web natin. Okay, tingnan natin, class. So, class, yung formula natin dito, class, para malaman natin percentage of the shear force that is carried by the web, that will be the shear force carried by the web over the total shear force, which is 16 kips, di ba? Yung given dito. Okay, so times 100%. So, to solve for shear stress, no, doon, or shear force pala, carried by the web, ito yon, yung V sub web. So, pwede natin gamitin ito, yung, di ba, yung formula natin, shear stress equal to shear force over A. No, so, dyan actually galing class ito. So, this is the formula that we talked about, no, doon sa discussion natin. No, yung shear force class carried by the web, yan ay equal doon sa cross-sectional area ng web times the area of the shear stress distribution, which is dito yun galing. So, itong area na to, ito yung area ng cross-sectional area. Tapos, itong stress na to, ito yon, yung area of the shear stress distribution. So, ito-drawing natin, class, yung shear stress distribution natin. So, this is the shear stress distribution, class. Dito yung kanina, class, no, dito sa may junction nung flange and web natin. Di ba na-solve na natin, class, yung shear stress dito. So, yung shear stress dito ay 4.148 KSI or 4,148 PSI. So, ito yun, class. Yung niya, no? Yung itsura niya dito. Okay. And then, dito, class, sa neutral axis, yung shear stress ay 4,917 PSI. So, medyo mas malaki siya dito, di ba? So, mas siya, mas, kumbaga, from here, no, aangat siya dito. No? So, dito yung magiging maximum niya. So, symmetric yan. So, pareho lang din yung magiging shear stress distribution dito sa baba. Okay. So, from here, class, no, yung area of the shear stress distribution na tinutukoy is itong area na itong na to. Shear stress distribution na to. But in this case, class, para di ka malito, class, itong 4,148 na to, ito yung height na to. So, parang to, no, rectangle. Rectangle to. Okay, so parang rectangle yan, class. Okay, so class, itong 4,148 PSI na to, so yan na yung value ng area na to, nitong rectangular area na to, class. Okay, yung 4,148, it already represents this rectangular area, ha? Okay, so ibig sabihin, class, kung sabi kasi dito, area of shear stress distribution, di ba, ang area ng rectangle, so consider lang natin to rectangle na to, ha? Okay, so, ang area, di ba, ng rectangle, base times height. So, yung height, let's say, 4,148. Tapos, yung base, ito, di ba? So, class, pero dito, in this case, since itong 4,148 na to, it already represents the area, okay, of this rectangular area, class. Okay, so, if base times height, let's say na yung base, class, ay 1. No, para lang di ka malito. Since base times height kasi yung area ng rectangle, di ba? So, yung height ay 4,948. Tapos, yung base class, 1 lang. Okay, para di ka malito. Para dun sa area na yun. Pero, ito pa, class, meron pa dito, di ba? May parabolic, pa dito, na portion. Ito, parabolic, ito, class. Class, recall mo, yung area ng parabola, ito. Diba? So, let's say for this parabola, yung base niya ay ito. Yung height niya ay ito. Yan ay 2/3 BH. Okay, so ito class yung parabola na to. No? So, yung base niya will be ito. Tapos yung height niya will be the difference of 4917 at saka 4148. Yun yung magiging height, diba? So, yung area niya ay 2/3 BH. So, in this case, class, yung B, consider mo 1 lang siya. Okay, para yung mangyayari, 2/3 H. Yun yung magiging area, okay, yung karagdagang area contributed, no, by this parabolic, portion. Okay, para dito sa area of shear stress distribution. So, in this case, class, yung magiging area ng shear stress distribution will just be 4148 times its base, which is 1. And then, yung sa parabola, yan ay 2/3 ng base, which is 1. Tapos, yung height niya ay 4917 minus 4148. Okay, so solve natin, class. So, for the shear force carried by the web, so again, that is just equal to the cross-sectional area ng web times the area of shear stress distribution. So, para dun sa cross-sectional area nung web natin, ito lang yun. So, ano ba ito? So, class, ito ay 11.9 minus yung dalawang 0.515 na thickness nung flange. So, isusubtract mo dito sa 11.9. So, that will be 11.9 minus dalawang 0.515. So, that will be 10.87. So, that is the height, no, nung web natin. And yung thickness ay 0.295. Therefore, yung cross-sectional area na to, class, nung web ay 10.87 times 0.295. Ngayon, class, for the area of the shear stress distribution, okay, so for the rectangular portion, class, base times height, yung base 1, yung height, class, ay 4148. Okay, and para dun sa parabolic na portion, okay, so that will just be 2/3 nung base, which is 1, and then yung height, class, ay 4917 minus 4148 para dito sa height na to. Itong height na to. Okay? Ayan, so this will be the, yung values, no, para dito. Okay, so solving for the shear force carried by the web, this is 14.945 kips. Okay, so pwede na natin plus i-solve yung percentage. No? So yung formula natin ito. So yung V web ay 14.945 over 16 kips times 100%. So the answer here, class, ay 93.4%. So class, 93.4% nung 16 kips, yan yung kine-carry nung web natin. So makikita mo dito, class, no, compare dun sa, kasi yung natitira na lang dito, class, is 6 point something, no? So, yung 6 point something na yun yung kine-carry nung mga natin, nung mga flanges natin. Eh, makikita mo, sobrang liit nun. Okay, so, as we can see here, class, no, these results, no, confirms that the flanges are ineffective in resisting the vertical stress. Okay, talagang yung vertical stress, class, no, yung nagke-carry sa kanya is yung web talaga. 93.4%. No, nung shear force is carried, no, by the web. Okay. For sample problem number 3, the figure shows the cross-section of a beam that carries a vertical shear force V, which is equal to 12 kips. The distance from the bottom of the section to the neutral axis is D is equal to 8.90 inches. No? So, in-indicate na dito, class, yung neutral axis natin. So, this is 8.90 inch, no, from the bottom. Okay, and the moment of inertia of the cross-sectional area about the neutral axis is I is equal to 547 inches to the fourth. Okay, so determine the maximum shear stress on this cross-section. So, in this problem, class, no, the vertical shear force V, it's already given. The maximum, or the moment of inertia about the neutral axis is also given. Okay, so we are asked here, class, to solve for the maximum shear stress, no, on this cross-section. So let's solve this problem. Okay, so class, to solve the maximum shear stress for this problem, so take note, class, no, the section here is not rectangular. No, it's not a rectangular cross-section. This is also not a wide flange section, no. So here, class, to solve for the maximum shear stress, we will calculate the shear stress at the neutral axis, no, and at level AA in the lower fin. Okay, so class, ganito ang mangyayari, no? Hindi automatic na yung maximum shear stress natin dito ay nasa neutral axis. Bakit? Kasi nga, class, merong, yung ano natin, class, dito, yung magiging T, no? Yung T para doon sa VQ over IT, paiba-iba. No? Kasi iba-iba, hindi lang ito rectangular, class. Hindi rin constant yung width nung ano natin, nung cross-section natin. So, yung width niya dito, iba. Yung width niya dito, iba. Yung width niya dito, iba. Yeah, iba-iba siya, class. Okay, so in this case, class, we are going to compute the shear stress dun sa neutral axis. Tapos, class, we are also going to solve the shear stress doon sa point, no, na yung T ay maliit. Mas maliit kaysa dun sa T dun sa neutral axis. Yung T kasi, class, dito sa neutral axis, 2 inch. So, hanap ka, class, ng point, no, dito sa section natin na mas maliit yung T, no, kaysa dun sa T dun sa neutral axis. So in this case, yung T dito sa portion na to, which is ito ay nasa AA. 'Di ba? Nasa level AA. So kailangan din natin, class, kunin yung shear stress dito. Kasi, class, yung T, ha, kapag maliit yung T, yung Q over T, lalaki 'yon. 'Di ba? Q over T sa formula natin. Diba? So i-compare natin, class, ha, i-compare natin yung stress na mako-compute natin dito sa neutral axis at saka yung stress dito sa level AA. Okay, so let's solve this. Okay, so we will start solving the shear stress at neutral axis. So, yung ano natin, class, yung procedure natin, we already have V, the shear force V. We already have the moment of inertia I. No, so we will now the neutral axis din, class, no, it's already indicated here. So the neutral axis is here. So we are now going to proceed, no, in solving the first moment of area Q. So, class, for the first moment of area Q, yung A prime natin will be the area above the neutral axis, since ito yung point na ano natin, no, ina-analyze natin. So, yung ano dito, shear stress dito. So, yung area na i-consider natin is ito. No? Pero actually, pwede rin naman na yung area below yung i-consider natin. Pero mas madali kasi kapag ito. No? Itong nasa itaas. Kasi rectangle lang to. No? So, solving, class, no, for the A prime. Yung A prime natin, class, base times height. Yung base ay 2. Yung height ay ito. Ano ba ito? 7.30. No? Yun yung area prime natin. Ngayon, yung Y bar prime natin, yan yung distance from the centroid of A prime papunta dun sa neutral axis. So, in this case, that will just be 7.30 over 2. Diba? Kalahati lang nito. Yung magiging distance from its centroid papunta dito sa neutral axis. Okay, so solve natin. So, again, yung A prime natin, that will just be 2 times 7.30. No? And then, yung Y bar prime natin ay 7.30 over 2. Okay, so solving for Q, that is 53.29 inches cube. Okay, so we can now solve, class, no, the stress in the neutral axis. So that will be VQ over IT. So yung V natin 12 kips, yung Q natin 53.29 inches cube. Our I is 547 inches to the fourth, and yung T natin dito, class, is ito. Diba? So yung T natin dito ay 2 inch. Ayan. So, the stress, class, or the shear stress at the neutral axis is 0.585 KSI. So, we are going to solve also the shear stress at level AA. So, dito yan. So, class, dito, no, since ito yung point na kino-consider natin, so, yung Q natin lang din yung magbabago dito, class. Yung shear, same, ha? Same yung shear, same yung I. Yung T, iba din yung T dito. Yung T natin dito ay ito. Ano to? 1.2 inch. Yung T natin dito. So, class, yung i-consider natin dito para dun sa first moment of area Q, no, yung area na i-consider natin, pwedeng itong below. No, pero pwede rin yung above. Pero kapag yung above kasi, class, yung kinonsider mo, medyo complicated pa siya, no? So, kukunin mo yung area nito, no, yung area above na to. Tapos yung distance pa nung centroid nung area na to, no, papunta dun sa neutral axis. So medyo complicated siya, no. So mas magiging simpler yung solution natin if we just use this area below. No, so this is just a rectangle. Okay? So solving for Q, yung A prime natin dito, class, will just be the area of this area below, the point na kino-consider natin. So, itong height na to, ano ba tong height na to? Yung base niya kasi 1.2, no? Pero itong height na to, ano natin, i-ano natin, this is ano, no? 7.5 dito. Okay, 7.5 siya dito. Okay, so, yung magiging area 1 natin ay 7.5 times 1.2. Tapos, class, yung ano natin, distance ng centroid nitong area prime, papunta dun sa neutral axis. So, ano natin to, i-analyze natin. So, ito, class, ay, ang kalahati nito, 7.5, no, over 2. Ito, yung area na kino-consider natin. Tapos, plus 1.2. No? Tama ba? Kalahati nitong 7.5, andito yon. Tapos plus, kaya lang pala, hindi pala, mali. Yung 1.2 pala hanggang dito lang. Ang kailangan nating distance from the centroid hanggang neutral axis. So, ano pala, 8.9, ito yon. Minus yung kalahati ng 7.5 para makuha natin tong distance na to. Okay. So, again, our area prime, class, area lang nito. Ito ay 7.5 times 1.2. Ito yon. And then, yung y bar prime natin will be 8.9 minus itong kalahati ng 7.5 para sa distance na to papunta dito. So, yan ay 8.9 minus 7.5 over 2. So, solving for Q, this is 46.35 inches cube. Okay, so, solving for, the shear stress. So, yung V natin dito, class, ay 12 kips. Yung Q natin, 46.35 inches cube. Yung I natin, 547 inches to the fourth. And yung T natin, take note, ito yon. Ano yan? 1.2. Ayan. So, in this case, class, the shear stress at AA is 0.847 KSI. And as you can see here, class, okay, so this is larger. No? So, this is greater than the shear stress at the neutral axis. So, ito, class, yung mag-govern. Okay, so therefore, class, the maximum shear stress, okay, so that is the larger value of the two values, no? So, therefore, the maximum shear stress, class, is 0.847 KSI, and it occurs at AA, no? At section AA. Okay, so this will now be the answer for this problem. So that concludes our discussion for this topic. I hope that you learn and attain the learning outcomes. Okay, so class, there's an assessment task for this topic. So answer that and then you're going to submit that on our next meeting. Okay, so aral tayong mabuti, class, and keep safe. God bless. God bless. Bye-bye.